All right, good morning everybody, and welcome to the second part of the Inspire Extensions workshop. So thank you all for coming back despite the call of coffee outside and all the interesting discussions we can have. Yeah, so for the second half of this workshop, who of you was actually not here in the first part? That's, 2, 3 people. Okay, so I'm going to do the 1 minute repeat, and then we'll directly delve into the core of the thing, which is actually designing the data specification extension. Yeah, so just to give you the 1 minute recap, in March, GeoNovum contracted us, WeTransform, to work together with a European expert group to determine, first of all, what kind of Inspire extensions are already there, and what kind of information do we as a community need to provide and collect to effectively build Inspire extensions. And in the first half of this workshop, we've looked at the findings from the survey. So you can also find that online. I'm going to have a look at that in a moment again. And we also had an in-depth look at how to actually perform the analysis part of the modeling exercise. And having said that, we are now in the stage, so we did our analysis, we collected the information about what we actually need to model, so what's in scope, what's not. We have described who is going to use that data model for what purpose, and we've compared our findings with the existing Inspire data specification. So we found out what actually out of the Inspire data specifications is relevant to us. Okay, so let me switch this again. We've also had a short presentation by Kati Schleit on one existing, more or less the first Inspire extension, as she said. And I'm also, now for this block, we have about 45 minutes of laughter. We have about 45 minutes of working on the design part and actually implementing that. I will also include a view at the tutorial, so there's a step-by-step tutorial that's part of the website that I invite all of you to have a look at, maybe afterwards or during the presentation. And finally, we will have another presentation by Stefania on a different extension that she has been creating for a project. And after that, we'll spend the last 15 to 20 minutes of the workshop to gather some of your input. To basically, I want to know from you what are the things that you were expecting, that you were missing, what do you think where this whole work should be going. We collected some of our own ideas on that already with the JSC and with the expert group and so on, but obviously this is a great opportunity to get feedback from you as a larger group. Okay, so like I said, the next thing that we actually want to look at is the actual design. So now that we've made our analysis, the question is, how do we actually create a proper data model from that? And as we said that we are going to create data models that are compliant with Inspire, there are a couple of rules that we need to follow with that. There are actually many more rules than those, but the ones that are in the generic conceptual model of Inspire, the core ones are listed here. So those are the things that you should keep in mind. There are also more, for example, related to the ISO standards that are referenced by Inspire. But what we wanted to do is really to provide reference to them in the tutorial, in the place when you really need to pay attention to them. I think it's really hard to basically, it's like when you tell a kid, here's 50 rules you need to remember while sitting at the table at once. I'm not sure whether that's going to work. It's probably better to just, when, I don't know, they spill the food to the floor or something like that, you inform them that's the place where you need to pay attention. Okay, so let's have a look at the design process as a whole. So for about 10 years I've helped organizations create data models, and some of that has influenced what we've seen here, but there's also been input from other groups that I thought was really helpful. So typically, the first step really is to decide what are the general rules that we are going to follow. There's the Inspire rules that at least if we create an extension, we basically always need to take into account. Also, and like Dominique suggested, we make a model that's Inspire compatible but might not extend one of the existing data specifications, we still need to look at that. I mentioned this briefly in the overview. There's two patterns for model compliance. There's the generic conceptual model and the CityGML application domain extension. So let's have a look at that. And this basically just very quickly describes what the general rules are that you need to keep in mind. So reference that. So that's basically a given for the situation that we're in. So you may not violate these things. All right. Then there is the actual step of creating your new model. So for example, let's say you're working in a UML modeling tool, and you might want to set up your model there. You could start from the Inspire UML model typically, and or start on the Green Meadow. Then for each of the classes, so we looked at in the analysis phase, we identified the spatial object types, the likely ones that we need to take into account. And for each one of these, we actually need to decide on how we are actually going to model it. And for that, we need to take a look at the class extension patterns. So let's have a look at those. So of these, we have a total of 5. So these are terms that many of you, I guess, know. There's, for example, there's aggregation, there's inheritance, there's association, composition, and multiple inheritance. And for each case that you're implementing, for each of your new types that isn't entirely covered by the existing data specifications, you basically can go through this table and note down which one works best for you. So you've learned a lot about the actual requirements that you have before, so you can ideally now make a qualified decision, for example, on whether inheritance is right. So, for example, if you want to create an association from an existing Inspire class, that wouldn't work because you can't change the core Inspire class, so you need to create a new type where you can add that association. There's also the question always, is it the right thing to do? Not just does it technically work, but in this case, if it's inheritance, it should really have an is-a relationship. So for example, you shouldn't do bird inherits from cadastral parcel. That sounds a bit weird to me, even if they share some properties. Yeah, and then there's also the question of how close do you want your coupling, for example, to be. If you inherit from a certain type, it changes the kind of pattern that you use to keep up to date with changes. So for example, you can basically just update the version of your imported Inspire type and see your type is already compatible again. Yeah, there's also reasons, for example, why not to use inheritance. So one thing is, that's been popping up a lot, you inherit quite a lot of baggage, literally. So sometimes you import a type, you inherit from a type that's in the Inspire schemas, and you get a lot of stuff that doesn't actually work for your particular process, or that makes it very difficult to adjust your own system to handle this kind of additional data. Another thing is, for example, also if your class has an equal relationship with multiple Inspire classes or local classes. So let's say, for example, you want to inherit both from an Inspire class and from one of in a national standard to be compatible to both, then simple inheritance would also not be applicable. Yeah, and ideally for each of your types, you go through the set of patterns and decide, okay, yeah, let's say, for example, aggregation or inheritance is the right one. Let's have a look at one. So the pattern descriptions always follow the same structure. So first of all, there's a statement about the intent, which is an explanation that I think most people who've had to do with some kind of model design or systems design or things like that actually can understand. So it starts at a level that I would say an undergrad in computer science would for sure understand, but it might be, and that's one of the things that I would like to know, it might be slightly too deep in some cases for a direct GIS user. So if these things need more explanations, then please let us know so that we can expand on that. Yeah, here, for example, in the case of inheritance, it states that it's a mechanism for reuse of software components, be it structure or behavior. So in software, there's always two parts. There's the data structure, and there's how it behaves, what methods it has, and so on. And in this case in particular, we have an inspire class, and we want to create a class that inherits from that. So for example, here we've used cadastral parser in inspire as a reference, and we created this joint parser that's a subtype of that. Yeah. Similar to what you've seen in that summary table with the pluses and minuses, there's also a note on when to use and when not to use in here. That's a bit more detailed. So if you were wondering what any of these points in the table, in the summary table where all the patterns were listed means, then ideally you go to this page and really look, okay, is there some additional explanation that helps me understand this or not here? So for example, there's this thing with a semantic relationship that's explored a bit here in detail. Yeah. Right. Okay, then there's of course also some when not to use information. So for example, those are the things that we've just mentioned, but there's also additional criteria in here. Yeah. So you should really look at these and think about, does my class actually satisfy the when to use criteria more than the when not to use criteria? And if so, it might be the right pattern for you to pick. And now the nice thing about a pattern is if you've chosen it, you directly get some input on how it's actually to be implemented. So and that's the part that we've added here. So there's, like I mentioned before, there's the XML schema example, typically with a couple of highlights. You can also download that directly here. So we've always included all the examples so that you can just get them and work with them directly. We also explain the example. So in this case, there are the things that how you actually implement inheritance on this XML level. And it's explained with a substitution group and the extension base that's used here. Yeah. And then there's, of course, how do we actually encode the examples? I'm not sure about you, but I've often looked for that. So I was often wondering, okay, so how should the data for that actually look like for that particular schema? And so we've tried to include one, or we've actually included one for every pattern that there is. There's always an example here. Of course, we've picked one example. It would be nice if you had an example for every theme, for example, but that would go a bit outside of what we could do here. Yeah, and then there's, I think that was also something that just popped up in the discussion before the break and also during the break. It's really important to take into consideration on how you're going to implement that, especially since you're making an extension for your business processes. So you typically know your implementation environment. So you know, for example, am I going to use an S3 enterprise geodatabase or I'm just using Postgres in that form? How am I actually publishing it as a service and so on? And you probably also know a bit about the limitations of each of these layers of implementation that you use. So it's really important to have a look at the implementation considerations and find out whether that particular pattern might give you some problems later on. The simpler patterns usually don't, but there are some which have a long list of implementation considerations that you need to then pay a bit more attention to. So for example, here in the inheritance case, that's actually, I think, pretty well understood. And there are many strategies of dealing with inheritance hierarchies on, for example, relational databases, which are also described here. And there's also a direct mapping to structures in XML, for example. So there's no big problem on that side either. Yeah, so that's also what's stated here. So there's always, in the implementation considerations, you'll have information on the storage backend, on download services, also on the business logic side. So the assumption is that that's usually object-oriented, and on the consumer side. So here, there's the big point. Most JS client applications actually do not really make use of the inheritance information and just process the instances as they are. So for example, if you use let's say the QGIS WFS 2.0 client, you will see that it just shows the instance as a tree, but it doesn't tell you that, for example, part of that might have been from a super type and part of that is just from this particular class. Yeah, inheritance is actually, I think I might have mentioned that before, is the example that almost everybody uses. So out of the 19 examples that are now in here, 17 use inheritance. So that's the list of those, and it actually goes on like that. So for the ones that we haven't yet added, it's basically the same pattern. It's by far the one that something like 90 or so % of all the extensions we've seen use. It's something that people who are used to data modeling usually understand quite well. So I've also not seen completely weird examples like, let's say, the aforementioned birds or bees instead of parcels. Yeah, so that was the second step. So we've now actually chosen a class extension pattern. So we've said, okay, we're going to use, for example, inheritance to relate our new joint parcel type to the Inspire cadastral parcels type. So we've created the class accordingly as a subtype in this case. Now we need to decide, okay, how are we going to actually add properties? And in the properties case, there are three basic ways of doing that. So there's simply taking one that is already there and modifying it in some way, or adding a new one. And adding a new one is something that we didn't really have here as a pattern, because that's so basic that you don't have anything special to consider here. However, for the actual modification, that's a bit more specific. So here we have this adding constraints one and code list extensions. So let's have a look at the adding constraints one. So that's basically, a constraint is always a statement that tells us, what exactly a valid data structure would look like. So for example, let's say the schema tells me I can have any string in a certain property. But actually what we want to say is there can only be very certain strings, like for example valid units of measurement in the SE units or something like that. And so I would add a constraint that specifies exactly what valid units of measurements are. And these constraints can be used in two ways, and both actually usually improve usability and interoperability. So one thing is that the constraint, in some cases, the models are very wide, the Inspire models and others as well. So they allow a whole lot of things. For example, there are elements where there's any type, or where there's other structures like any kind of geometry. There's just abstract geometry. There could be basically anything below, right? And with the constraints, I can in these cases downscope the whole thing and make it clear that in this case, for example, I'm expecting a curve or a line string or something like that. That makes it much easier to achieve interoperability on all sides. And the other thing is that I can actually improve the data quality. So I can make it clearer what my intent is, what do I really need, what do I really expect in terms of the data that I'm reading. So yeah, one should always think of these patterns to be, especially these ones, to be additive. So they are not mutually exclusive. You can't do just adding constraints. And then there's the code list extension. That's kind of a special case. So I guess most of you have heard of a code list before in the Inspire context. Yeah? Nobody doesn't do that, never heard of that. Yeah, so code lists in Inspire are a kind of interesting construct because they can be hierarchical, they can be extensible, and they have a couple of other properties. And in the cases where they are actually extensible or where there isn't a code list defined a priori, we can create our own or just extend of one of the existing ones. So for example, in the Inspire encoding of code lists, there's this explicit statement about the extensibility. In this case, it's open, so we can add anything at any level that we want to. Yeah, and this particular pattern describes how we do that. So, for example, how an extended code list has to be built, what it looks like. Again, there is an example, how it looks like in the code list and how the references to it will look like in the GML. By the way, it's still one of the questions that we get a lot, is the transition from GML 3.2.1 style code list to 3.3.0 with the reference type, so that still pops up a lot. And that's also why we thought it's important to include this. Little pointer, one thing that we also learned is that there's a recommendation as a best practice to also always include the title, so not just the href value to reference the code list value, but really also to make a readable value in addition to that. All right. Yeah, of course, there are also implementation considerations for that, and actually one of the most important ones is the one that we heard about earlier, and that is so that a code list can work, you need to publish it somewhere. And as we've heard, there's work ongoing to make that part of the registry, so that we have an easy possibility to publish code lists in the future, which right now is a bit of a mess, to be honest. Okay. yeah, so that's the properties level extensions. Okay, so coming back to that. So what we've basically done now is we've taken 3 hierarchical steps. We first said, okay, we're going to build a model according to these rules. Then we're building a set of types, and we're using these and these patterns. And now on the final level, we're saying, okay, what do we do to define the properties individually? And yeah, after I've done that, after I've added the required properties to new classes, the final step is really to look at, okay, are we there? What do we need to change? And the typical way that we work on this is in multiple iterations, like I mentioned before. A methodology I like particularly because it yeah, basically gets input from everybody is to use the so-called Design Studio methodology, where this is actually not done in the group, so the steps 1 to 6 or 1 through 7, but rather by everybody individually. So let's say you have 3 domain experts, and everybody individually does that process. And at the end, they present the model, their particular draft, explain why they did it very briefly. And then everybody else in the round gives their feedback. So this is here, this is yellow circle, feedback number 1. So after everybody has made a draft and presented it, we all aggregate the feedback. And the feedback is always structured, what did you like, what didn't you like? And then all that aggregated feedback is used to create a second draft and maybe need a second feedback round. But usually the different model designs converge very quickly in that process. So I've seen getting to very good results within 1.5 to 2.5 hours here, depending on the model size, obviously. I mean, if you have a model that has dozens or hundreds of classes, what I would recommend is picking parts of the model and doing the same exercise on the parts one by one, and then at the end consolidating the whole model. It doesn't make sense to try in one iteration to model the whole world, even though I know that makes fun, and it's a nice thing to feel that I've built this gigantic model and it's all consistent and so on. But especially if you have a team and you really want to get the input from everybody, it's better to basically approach the stepwise and to have well-digestible chunks and not the whole yeah, completed work at once. Yeah, and that typically with about 2 feedback iterations gives you the initial design. So typically with a second feedback iteration there's only smaller changes, and normally we have one person who consolidates these. So we have 2 rounds where everybody is able to give their input, and then we have a final consolidation round that's done by one person. And yeah, so like I said, this process basically ensures that we really take into account the different views of everybody. What happens otherwise is, so if you have one model from the first moment on, and everybody actually tries to contribute to that one model, typically contributions will be very uneven. So some people in such a team setting might be very dominant, others are more not so much willing to go into this, and so on. So if you really do this in that process in a team setting, it's very hard to get equal input from everybody. But doing this comparison, so for example in this group, they actually made it on whiteboards, so everybody made their design on one whiteboard, and then afterwards they went from one to the other, and everybody gave their plus and minus input. They were also able to do that very quickly to get a good result. Yeah. Generally, this is also the hint here again. So if you're designing a large model, split it up into chunks of maximum 8 to 10 classes to keep this process effective. So yeah, I think that the largest standards that I've seen so far had several hundred classes, so obviously then it takes a while. But then again, it's also a question of scope. So really, do you need to take so much into account for one Inspire extension, or should that better be separate projects? So I would normally recommend to keep well-separated modules if possible. It makes maintenance also much easier later on. Yeah, so when you've done that, you actually have a draft model. And the draft model, so I mentioned this before, I personally recommend actually using pen and paper for that. So in this case, there were like table templates. So imagine it's a table with 2 columns, attribute name, attribute type. That was just printed out previously and people could fill in by hand. That's very low tech. It doesn't require licenses of some software, and it doesn't require a priori knowledge of how to use a UML editor, for example, but it just works. and people could also draw connections and so on. So it's really about capturing the design intent. And then typically the modeling expert that I mentioned before, or the project manager, whoever has the expertise, really creates the first UML model. And that's then done in, for example, Enterprise Architect or Argo UML or any other tool that you want to use. Okay, so going from that, the next step is creating the implementation level model. For that, there's, depending on what you do, there's not too many different choices. But actually what you need usually is to really go forward, to test your model. You want to create an application schema for your download service. You might need a relational database schema, and you might need a couple of other things. For example, one project that we're currently doing, we're also generating domain class models directly from that. Yeah, the tool that's most used for in this purpose is ShapeChange, which I guess many of you have heard before. It's also part of the tutorial here. So when we've done that, then comes an interesting part. So now it's about finding out, okay, we've now created a data model, and we want to learn how well does it work for our purpose. So we have to validate it, and there are several different ways to do that. One thing is that we can validate the schema itself using the site toolbox, where there are possibilities to validate the schema itself. There are also scripts that can be used for that purpose in Enterprise Architect, so that you know whether the model is in itself consistent. But then we also still have to know whether it really works on the technological side and for the user. And for that, the thing that we need to do is we need to integrate data. So we need to take our new model and our existing legacy ones, or local standards, and need to transform data. There's two ways that is done usually. So in one is more a conceptual approach, which is the matching table approach, where we in theory look how well is the coverage between the source and the target models. The downside of that is it's not formal. So in my experience, a lot is left out in these cases. So we've just done a larger project mapping a German standard to Inspire, Annex 1, and at least 50% of the work that we had to do was not captured in the matching table, conceptual work. I'm not talking difficulties in implementation. Yeah, and but it's a good start because it's a very low-tech tool. Everybody can use it, so it definitely has some advantages. Yeah, and I would never say it's not workable. It's just that with large data schemas on the source and the target, it can get very complicated to actually understand still what's going on in the matching table. Just as an example, I printed out one of these that we worked with, and even in A3, and still only this font size, it was 30-ish pages, sorry. So it's really hard to understand and keep an overview of. What we've been working a lot with is the declarative mapping approach. So that's basically, again, it's a statement of intent. So I'm saying, for example, I want to have this class from my source type to be retyped into, for example, some land cover class. And that can either be done with data or without. It's really about capturing what should be connected from the source to the target. Yeah, there's a number of specific tools available for that. It might not surprise you that I mostly use Hail, having built that software for 7 years now. But there's also alternatives. Yeah, and the nice thing is, in any way, what I need to do is if I want to do an analysis of how well my model is suited, I need to do an analysis of transformed data. So I need to check how well my existing data actually works in the transformed model and how I can use that. And things that we typically look at are, for example, is it efficient in the sense of, did I just create a whole lot of additional structure that makes it really hard to work with this? Classical example is I mentioned CI citation before, so if I need 10 levels of attributes to store a single value, that might not be the most efficient way of doing it. It might still be required, but it's a trade-off that I should be aware of and that I need to knowingly take into account. Model complexity is also an interesting one. So, I mean, I'm aware that often we just want to display a very rich data structure, and there's no way around a certain complexity. But we should be really careful with unnecessary complexity, and just being aware of the complexity that we are currently dealing with is very helpful. So, for example, we're typically looking at measures like how large is the model, how deep are nesting and inheritance structures, does it have large loops? That's a classical trap. So For example, in one model that I've analyzed, I found a loop across more than 50 classes. So you go through the whole data structure, and at the end, there's a loop again. And these can be really a pain, to deal with later on. Then there's also conceptual mismatches. Things like, for example, mapping a classification. Let's say a road classification. One country has 5, the other country has 8 levels of roads. And you map both of them into the Inspire shared mapping. That actually means that there is a loss of information here, of precision and so on. So we have to take into account whether that works for us or not. So we really ideally document these conceptual mismatches. Or we might have to change the schema in the end. And then another thing that I think is very important is, I've seen this also happen, is that people get a bit carried away in what they are modeling. So they're building a very big data model. But at the end of the day, it's really interesting to see whether we can actually cover all of that. So do we actually have the source data to fill the model? That can look, for example, like this. So this is a hydrophysical water schema and a couple of smaller data sets. And we just analyzed, so that's one of the tools that we are using for these processes, to find out how much do the data sets that we know of actually cover the schema. So for example, here we see, okay, it's a standing water object, half of these from the data set, and yeah, some of the properties are used a lot and others not so much. And in this case, we can very quickly find out, by collecting the different data sets and transforming them, which parts of the model that we designed might not actually be usable at all because we simply have no data for them from any source. Yeah, so going back to this. So that's the model coverage part. And if we've collected that feedback, we can actually say, okay, now we know what the quality of our model is to some degree. The missing part is still actually using it. And that's something that in Inspire we typically achieve through either just writing files and creating some kind of predefined data sets, or we actually create a direct access download service. So typically what we do is that we do a data publishing process, so the transformed data that we've created before, the harmonized data sets, is provided through a service interface, for which there are several different ways that we describe here. Yeah. The easiest way is just trying to load the files. That's the first thing that is already good to do. However, it's also often important to find out whether the files that I've created or the data structures can actually be served by the software that I prefer to use. So yeah, Kati could tell a lot about these stories, and Stefania too, and I guess many of you as well, that often there are some traps like, for example, higher cardinalities on properties on the first level or other things that somehow throw off the whole process, and then you have a half-year delay waiting for the next release of server or something else before that actually works. So when we've published that, obviously we finally want to know, does it fulfill the process needs that are there on the site? So we ask the stakeholders, okay, please access the service and tell us what problems you encounter. So there's typically a lot of feedback coming from that as well. And there's also another thing that we need to do at that stage, which is after we've published the data, we typically want to validate that. And there's, nicely enough, there's a couple of validation services by now available, for example, by GeoNovum or the GDIDE test suite, and many others that you can use to actually find out where your data is compliant with the Inspire requirements and others. Yeah, and that's the point where I mentioned, so now you've collected all that feedback. Is it valid? Can it be used? Is it efficient? And so on. And now, at some point, you will feel happy and you will think, yeah, okay, this works, looks good enough. Our stakeholders are happy. So let's transition to operational usage. So that's the final step here, is basically to operate that. So that involves maybe making changes also to make the system scalable and so on. That's also something we have to take into account. And especially managing updates from the beginning on. So whatever process you use, make sure you take into account that you know how you will deal with updates of your data model in the future. All right. So that's the methodology. Any questions at this point? Dominique? I'm sorry, just a moment.
Make some cleaning instead of adding things, but deleting things. There are many attributes that are not avoidable in Inspire.
Yeah.
So other examples about models deleting this method.
Yeah, so the thing is that we decided in the end not to have an explicit pattern about removing things. Basically, it's not that easy to remove something without breaking Inspire compliance, right? So we don't make it a recommended practice. Rather, if you don't want to inherit too much Inspire baggage, so to speak, I would take the reference pattern. So there's one of the class patterns here. Let me just go there. It's association. And association is the pattern that you use if you basically want to have only a loose coupling. So you basically just point to an Inspire object, for example, from your object that contains some additional information. And I would rather use that than working with a hand-modified Inspire schema where I've thrown out a whole bunch of stuff. Yeah?
I would like to have a better idea about the compatibility with extending the Inspire data modeling and the validation. So for me, the question is, beside of an extension, do we have some constraints regarding the test use validation for Inspire? Do you see that there could be some issue if we decide to extend the model regarding the classical validation and purify data content?
I'll take it, okay. So the thing is, there are lots of rules that apply to all models, basically, where we say they are supposed to be compliant to the generic conceptual model. And then there are special rules that really are thematic, more or less. And for these rules, you've actually worked on a project, I think it was eEnvironment Plus, right? Yeah. To create specific validation rules for the Annex 1 themes related to environment. Obviously, we could still use those on some kinds of extended data sets, but it would be difficult. So in this case, actually part of the work that you could be doing is also create your own, for example, schematron validation rules and provide them to the service. So the service that you're using that allows you as a user to also specify your own rules in addition to the general ones. Is that clear? Or?
More or less, but it seems that if I understand well, it's not really solved in a way, because for me the question is how the user will look at that to see what is typically Inspire and extended. Is that possible to make a clear difference when they look at the product at the end?
Should be, yeah. Yeah, do you want?
For example, let's make an example.
Yeah.
One extended schema, for example, is CDDA, which extends Inspire protected sites. When you open the application schema, you can see the tags. Okay, in the heading, you have the tags which are related, each defining the relevant application schema. So when you find an element with, for example, the CDDA tag is from CDDA extension. Then in the nesting, you can see PS, for example. When you find PS,
Okay.
I hope I was clear.
Yes, I understand more or less the idea. But okay.
Okay, thank you, Stefania. One more question before we move on? Okay. The final part, so if some of that sounded a bit academic, what I just explained, then yeah, lucky you, there's also a clear, I hope, step-by-step tutorial that you can follow that basically takes the methodology that we've just discussed and really goes through them step by step. We've picked, let's say, some common applications, but we are aware that some of you use other tools, so you might use FME instead of Hail, or you might use GeoServer instead of Degree. But in the end, the scope of this exercise allowed us to pick one tool for each category. That being said, if you want to contribute basically the same flow in the tutorials for a different tool, please do so. So we've foreseen this from the structure, it's easily possible to make this switchable. Yeah, and here it's really, yeah, more or less what we've done here is we've picked up the CDDA example. So CDDA is a mechanism for reporting related to protected sites. I hope that was a somewhat acceptable one sentence definition. And that's actually something that's being worked on. So there's an official extension, but we've picked this example for this tutorial so that you can really walk through with a relatively simple case and do all the things that we talked before, like the actual modeling with Enterprise Architect, the data transformation later on, and so on. Yeah, so this tutorial typically will take you maybe half a day to go through. So if you feel unsure about any of the things that I mentioned but would like to start an Inspire Extensions project, I would recommend that you take a look at this and invest a bit of time to see whether after that you feel secure. Yeah, and of course it ends after some work with a data set that you've published. So, yeah, that's more or less the end of the official presentation regarding the methodology and the tutorial and so on. So we've worked with the expert group and with GeoNovum in the last months intensively on providing that. And for us now, of course, it's interesting to see whether that will be helpful, how much it's going to be picked up, whether there's still coming contributions and so on. And we will also have a discussion about the future of this. But before we go into that discussion, I would like to give Stefania Marrone from Epsilon Italia the opportunity to present another extension that was actually created also in a project called GeoSmart City, and where many of the same principles were used that we've just explained. That also might make it, yeah, I think that's a better method than trying to click through the 4-hour tutorial in the remaining 15 minutes or 20 minutes. Yeah, so Stefania, if you want to.
Yes, okay. Good morning, everybody. I'm Stefania Marrone, as you have already heard. So, I was involved in extending schemas related to GeoSmart City. The GeoSmart City is a project that is still ongoing and aims at implementing a platform for the sharing and publication of geographical open data. There are several countries involved, 11 countries, and we had to provide data, open data, according to a common data model. So being European countries, Inspire was the right choice to underpin the construction, the development of these new application scheme, common application schemas. There were in the project two scenarios. Green Energy 1 that aimed at supporting implementation of energy efficiency policies, and particular focus was on energy performance of buildings. And another scenario was related to underground, so the management of underground utilities infrastructures. And today we will see the extensions we provided for the green energy scenario, that is the building extension. which was our starting point. First of all, collection of requirements from different pilots from different member states. So the methodology Thorsten just showed is the one that we followed, almost, I guess, step by step. So at first we contacted the pilots and have their requirements, try to get a set of common attributes needed. And then we compared what we had from pilots, or requirements from the pilots, to what already existed in INSPIRE, that was the building data theme, so the building data specification. And what is written in the data specification for those who want to extend, not to lose the richness of local schema semantics in the different countries. The data specification says, this is a screenshot from the building data specification, that data producers may extend INSPIRE provided that they do not break any rules provided in the generic conceptual model. So we wanted to start from the core, so the building core. And in this case, an extended schema for the building is already provided in the technical guidelines, but it is a draft. It is not provided in INSPIRE official repositories of schemas. And then we wanted to add our own extension. So our first idea was to start from the INSPIRE core data model, so the building one, and inherit also the extended data models from INSPIRE buildings technical guidelines. And this was our first attempt, but when we put, let's say, our fingers in the pie, we could not use this approach because there were some issues related to the extended application schemas provided in the technical guidelines. There were some errors in the application schema itself, so we decided to provide our own extended data models beginning from the core and inheriting, let's say, reusing, in the sense of reusing and not inheritance that we see as a methodology for extension. So reusing needed concepts already described in extended INSPIRE data models and energy CTGML. So first thing we did was to use the matching tables to identify corresponding concepts, so attributes, associations, and code list between INSPIRE application schemas and the requirements we collected from the pilot users. And then we used the Enterprise Architect software tool to create the model using UML. And then, okay, maybe it's better if we go, okay. This is the UML of the building from INSPIRE building data specification technical guidelines. On the left, let's say light green, we see the core, the building core. And on the right, so the dark green, we see the extended. So this is the base on the left, and on the right, there is how INSPIRE extended already the building model. It is draft, so it's not official. Remember this, the extension is not official. And in our case, not so many changes were required because we just needed to add features and attributes related to energy performance of buildings and to model photovoltaic and solar panels, generators. Where was the problem? The problem was that in this UML modeling, there is a double inheritance on the building feature type, circled in red, and this creates an issue in the application schema, because according to XML rules, you cannot inherit from multiple classes. So, how did we resolve that? Okay, we can see that here we have double inheritance from two feature types, the building info and the building. So the feature type building inherits the class, so all the attributes and the methods from the building info and from building. In this case, we turned one of the generalization to a simple association. So no more the generalization, so the arrow here, but a simple, not the inheritance, but the simple association. Where is it? Okay. Oh, what is happening? Going the wrong way. Sorry for that. We also realized that actually we did not need a feature to model the building info. And so we decided to reuse attributes defined in the extended schemas in our own defined class that was a data type that we could also reuse in other application schemas. So first thing we did was to solve the problems related to double inheritance, multiple inheritance, then transform a feature class in a data type. What is important here to be stressed is that in this case, okay, we are just extending the core. We use the extensions provided in the technical guidelines and which are not mandatory for Inspire. They are drafted, so they are recommended, just to reuse same concepts already defined there and not redefine somehow. But we created our own extensions of the core. That's why we could turn a feature type into a data type without breaking any rule. Because this feature type was not contained in the core, but was contained in an extension. We did not inherit in our extension. And so what you see in orange here are the concepts that we took from the extended schema, but redefined according to our own needs, also adding some attributes, such as, for example, the solar potential, which are linked to the energy performance of the buildings. What you see here instead in dark green are feature types and data types already defined in the draft schemas that we used as is. We just copied them in our extension without modifying anything, but without inheriting. That's important. And So we use, for example, the installation concept that was present in the extended schema, and specialized it to obtain to model the concept of photovoltaic generator and solar panels. So in the right there, we don't have any 3 minutes left. So very quickly, we in this case we use so we copy the same class, then extend the class already defined in the extended that we copied. That is the one in green at the upper right corner. And what you see in light blue is feature types which we added. So we created to model photovoltaic and solar panels. Code list. One important thing we had to face was the code list extension. We decided to reuse the registry software, which is open source, freely available. We created a registry and published it on the hub, on the GeoSmart City hub. So it's, according to SPILE, extensions must be publicly available, and this is available. And what we did, okay, when we extend an Inspire code list, in the registry, we redirect the link to the original value published in the Spire registry. Other values are in the same code list, but if are our own values, so values that we defined according to GeoSmart City needs, they are redirected to the values present on the GeoSmart City registry. I don't know if you have any questions. Thorsten said I'm done. So have you got any questions? I know that in a few minutes it's not so easy to, yes, Chris.
Thank you, Stefania, for a very good example. If I would be interested to have a deeper look in the data model you just discussed, where is the document? Where I can really access the...
Okay, thematic cluster, you should know. Okay, on thematic cluster, there are evolution and thematic extension. So click on this and search for extended building. Of course, also the underground network extension is published, then you can find it there. That's it. Thank you. I wanted to add just one thing. We add the possibility to put into practice, so to use the extended schema. We created the services with degree. And for those of you who are interested, services are published also for CDDA on EEA data and are publicly available for those of you who want to see. And what is another thing that is important is the validation not only of the schema, but also of features served by means of WFS, in this case, if they are according or not to the schema, and if the extension you made provides data compliant to Inspire, or the Inspire schema you wanted to extend. Other questions? No hands raises? I guess it's the right time to stop, so thank you.
Yeah, Stefania, thank you very much. Very much appreciated. So yeah, you saw that was a bit more complicated case where it wasn't as clear-cut as in the first example what the options are. The structures were a bit more complex. yeah, I hope I didn't cut off too much of the story, so to speak. And yeah, however, I also wanted really to give you feedback opportunity, so I can tell you a bit about what we've considered our next steps could be. Let me switch back to the presentation. Yeah, and to summarize, obviously, what we've just discussed. Okay. All right. Yeah, so basically, where do we think we could take this from here? More or less as a baseline for our discussion. Yeah, so we think our impression is that we've started something that's useful here, but obviously the proof is in the eating of the pudding, so that's basically what you have to tell us then in the next months. The site became complete only a couple of weeks ago. Complete is obviously something that I don't think of as meaning stale, and it should just not change anymore. The opposite is true. So from our side, we will actually continue to develop parts of the software that are underneath of it. So we want to add more features to the website itself, to the Inspire Extensions website, such as the ability to have directly sandboxes online where you can quickly create a stand-up service or do a data transformation or create a model extension in a simple way. There's also an idea to, right now, I mentioned in the beginning, it's entirely possible for everybody of you to contribute to this. But I've also learned that not everybody feels really safe with all this GitHub-y stuff with forking and merging and pull requests and whatnot. So there were also ideas to make that self-registration much easier so that you can register an Inspire extension with a simple web form instead of having to go through the aforementioned process. Yeah, we've also, one of the things that we really would like to do is right now, we often have, let's say, some metadata on the actual models, but in by far not all cases we got our hands on the actual models. And just for those models that we looked at, we already found there's some discrepancy between the analysis of the models and the actual things that people wrote. So, for example, in terms of which inheritance patterns did you use, maybe somebody misunderstood what association means and checked that, and then in reality it's not in the model. Yeah, so we want to include the actual models as far as possible. That also goes in the direction of the question that was just asked, so where can I actually find it? For some, we've included it where we have it, but for many, we don't. So that would be really good to improve value of this resource. Yeah, we also want to include, we want to work on basically seeing how can we make this an official part, more or less, of the Inspire toolkit. For example, which part also the interactive data specifications are. And obviously, there's lots of other ideas. So, for example, we could add more information on the base standards like UML modeling requirements and ISO 191XX stuff and so on. One more idea was extending the tutorial itself. Like I said, there's the idea to add other tools. GeoServer might be a candidate. FME is another obvious one, and so on. So there's a lot of things that we can do in the future, but actually what I would really like to hear from you is your wish list. So maybe as my first question to you, so what are the things that you think are valuable in the in what you've just seen in the past 3 hours, more or less? Chris?
To break the ice, I would say the most valuable for me is that you not stay on the UML level, but that you go down to the encoding. So this is for me to really see how our extension mechanism works on the XML level is for me the most helpful.
Okay. So you would say the main challenges are on the implementation side, going from conceptual to...
Yeah, different levels, and one is better explored than the other.
Okay.
This is why this is very helpful. I think that you go to across level, not just the underlying level.
Okay, thank you.
Extended
Yeah.
or the elements in the application schema, you will probably so bang your head against problems with creating the services.
Mhm.
So the simpler the model is, the best you are able to create services. And maybe giving some example of help.
Mhm.
So what is critical
Yeah.
from the server part in the data model?
Mhm. Yeah, so I've noted it down, but I have to think a little bit about how to best do that. Yeah, we've tried to keep the tutorial, for example, very specific. So it describes exactly one way, one relatively straightforward solution, more or less. But obviously there's lots of problems that you will run into as soon as you deviate from that tutorial more than, let's say, half a meter. And so the question is really, how can we capture all these different challenges that are going to be out there? And yeah, one thing, for example, might be adding a troubleshooting section or something where we can collect or reference best practices that people mention. For example, there was recently this big discussion in the thematic clusters platform about is there a way of actually achieving fully compliant download services that a lot of people got involved in. I think that was very interesting. And it's condensing that whole discussion into like 3 do's and don'ts. Everybody awake again? Great. Sorry. That might be really helpful.
For me, it was very interesting to see the management steps.
Mhm.
Which sort of know-how do I need at which moment in the project? So it is very helpful to find out at which moment do I have to bring which sort of people together to go into the process. Because sometimes if you start, you have perhaps the wrong people together and they are discussing something. And when you ask the question, what are the next steps, it is sometimes not possible to give the right answers. So for me, it was very helpful to see which steps do you follow and which sort of people do you bring together. Thank you.
Okay, thank you. Yeah, let us know when you've applied it and have some additional feedback. Anything else? Yeah, Dominique?
There was something very interesting about when you show how much the attributes were populated or not. Was it done manually or
Well,
automatically?
I used for several years more or less some scripts for that, but we now have an online tool, and actually that will become also part of the site, so you can directly try it out there. It's basically you upload a number of data sets and they are analyzed, and the schema coverage report is then generated from that. So if you want to know more about that, I would recommend that we have a look at that later.
I'm thinking, for instance, in the health project, it would be interesting to have this kind of, in a way, metadata to show how much the data is populated in general.
Yeah. Yeah, in Hail you already have that. So when you transform data, then you always have these counts and so on. And that's just a nicer way of visualizing that.
Yes,
So
with several data producers.
yeah. Okay, thank you. Yeah, okay, then let's come to the really interesting part, which is what did you miss? So are there any things that you didn't understand that were unclear, where there should definitely be improvements? Yeah, just let me know. One suggestion already came from Stefania, but I'm sure at some point in these 3 hours I did something that wasn't clear, or maybe I completely forgot, yeah?
Would you organize some training or something?
Yeah, yes. Well, actually this year we've done probably something like 10 courses that had parts at least of that as content. I mean, I should say that much of that is really coming from a wide area of activities. So for example, we had this big Humboldt project some years back, and parts of that come from that and so on. So yeah, we can do a training. The next one will be with GeoNovum in October actually, but I think it's booked, right? Chris?
Maybe for matter what would even help to understand it better. I speak of my experience. I always look at other examples. So, such you said that there are examples where you collected metadata. You also said that some of these examples are basically difficult to understand because they are in natural language. They are not documented in URL. Maybe they aim at another encoding format. So, if you could pick out next to CDDA and this joint master example, which was very simple, you could pick out some well-documented, more complex examples like Stefania showed, and just directly point to them.
Yeah.
So then we could look, we could learn, we could understand, we could see different approaches because with the tutorial on CDDA, which is very fine, but as you said, people will orient, and maybe they will do the same things despite they are not fitting to their case. So just because it's shown there, so the more variety of well-documented best practices, which you could choose from the best practices or from the extensions you collected.
Yeah. Yeah, I think that's actually a request to all of us. Yeah, because we looked really long for suitable examples, and the combination that you've just explained, like well-documented, actually open in the sense of I may use it, so there's no license constraints, and ideally in English, or yeah, I mean maybe we can soften the last one because that would already give us many other options. Yeah, it's not that easy, but actually if you have something in mind that you would like to see added, then just shoot. What else? I'm going to stand here awkward for at least 30 seconds. Yeah, Dominique?
It would be to extend the scope and not only to have pure extension, but compatible models, and maybe when we do this, what is the risk and what is the benefit and what maybe is the drawback of getting a little further from the slide.
Yeah, okay. So I think that makes sense to actually have that. I mean, for me now it's, for example, using the association model is like an Inspire extension light, more or less, when you really don't directly reuse any types declared in Inspire and you just use references to point to a couple of them. But obviously there's a whole lot more to take into consideration when you're building an Inspire compatible model, even if you don't reuse the themes. And it might make sense to provide some additional information that just highlights that subpart of the workflow. It's basically the same approach, but not exactly all the steps, more or less, I think. Yeah?
Right job.
Yeah, yeah. Yeah?
I would argue the same way because, of course, when we think about extension, the first is that we have our own data source that we want to provide in Inspire languages. But we could lose, in a way, the interoperability with the others who are also providing Inspire data. So for me, if we focus on that, okay, we provide the data we would like. But if we had a member trying to get more data, maybe providing another extended data model. My question is, have we really analyzed the interoperability matter? And, well, this is part of, well, are we able in a way looking to Inspire data specification to say, we have the core data model, it's clearly identified in the extended model we have. So for me, that could be a solution to see, this is the extent part, and this is the core data specification everyone use, and the other is not used for some So for me, it's really looking to this interoperability, everyone deciding an extension. I don't know if it is a discussion or if it is some things we can solve right now with your tools.
Yeah, well, this is only in part a tools thing. In the end, I think Inspire is about achieving interoperability for a lot of purposes. So, for example, we've one organization that we're working with, because it consists of over 100 actual municipalities and so on. And there they also have the same goal. They also have to decide, okay, what is actually, how can we implement Inspire and also be interoperable with each other? They've actually taken the approach to make two separate data models and define them in such a way that they can be mapped very well. So that you can basically say, okay, we have a separate model and we have the Inspire model, but the mappings are really very simple, straightforward. That's, for example, another completely different approach than, or not completely different, but somewhat different than what we've just discussed, which usually helps fulfill both needs then. So that might also be one thing. So maybe there's, there should be a section like, I don't know, alternate approaches, just discussing them, or complementary might be a better wording. Just note that down. All right. No, I was looking at you and thinking of lunch, but don't ask me why. Yeah, I was just wondering, so on a scale of 1 to 10, how hungry are you by now? 6? Okay. 7? Good. 1? Okay, so you have another question, right? Yeah. Okay. Well, in that case, I think we're pretty much through. I would be very happy if some of you could discuss with me during the week what you think, where this should be going long term, for example. Also, if you looked at it at any point and want to give some more feedback, didn't understand anything, please reach out to Jan, Dirk, and me. And yeah, I really hope that there will be opportunities to continue that. I think it was great being able to do this project in the last half year with GeoNovum. And yeah, like I said, I'm looking forward to continuing this. So thank you very much all for attending, and enjoy the rest of the conference.